Hello, you absolute legends. My name is Don Cavanaugh, and what I want to talk about right here is the structure of hydrocarbon molecules and just being creative with how versatile carbon can bond. First thing about organic chemistry, carbon bonds 4 times. Just deal with it. There are times when it's 3, sometimes 5, but 4 times right here. We are going to draw and be creative as possible with structural isomers of 5 carbon molecules. So kind of the simplest one is a straight chain. 1, 2, 3, 4, 5. That's one version of a straight chain. 1, 2, 3, 4. Now what if I bend it down there? Did I really draw a different molecule? Consider if I count my finger, this is not really a different molecule. Although it is bent, it is really just showing a two-dimensional static image of something that is moving all the time. This is not a new molecule here. Okay. This is now a different molecule. If I count my fingers, okay, it's a new molecule here. Here's another. Okay. Is this actually a new molecule? I argue it isn't. I argue that these two are identical. This one is just flipped the other way. And if I try to count 1, 2, 3, 4, 1, 2, 3, 4, come up with some things right here. So this is only 2. Okay. What about some rings? Let's make it 1, 2. I would argue that this and this are still the same molecule. That this is just turned a little bit, and all I did was just crook the molecule here. You can see how these are just turned 90 degrees. So this is part of the creativity I want you to explore in OChem, is the ability to draw stuff on paper and see how they're identical or different. If you're having trouble seeing that these two are identical, don't fret, but just get comfortable with trying to look for that. All right, I'm still trying to draw a third structure here. I know I got one. This one is here. Boom, that's a new structure, okay? I have a carbon in the center that's still bonded 4 times. That fits my rule, and I have this thing right up here. Okay, now let's start drawing some rings, because I think I've exhausted all of my linear combinations. Keep it simple. Just like a classic house, cyclopentane. Let's draw another one with a ring right here. And have a carbon dangling off. And I could play this game where I draw my 4 square and then just dangle that 5th carbon off different corners, but I hope you can see that they're all identical, just 90 degrees turned here. I can think of another one. I'll try to make this look like a coat hanger. So I have a 3 carbon triangle, and then something dangling off the top, 2 carbons off the top. I can draw another 3 carbon triangle. Ooh, and see what I did there? I have 3 carbon triangle, the parent chain, a cyclopropane. Then carbons dangling off of here. What's another 5 carbon isomer I can draw here? Well, I'm not going to think about it too hard, because I do also want to address that these are all alkanes. Okay, now what is specific or special about that word is alkanes. These are all alkanes. These are all alkanes, and that suffix alkane is chemistry vocab that these are all single carbon bonds. So between all of these isomers I've drawn here, all the bonds are just single bonds. So I can say these are all alkanes. Now, I can make these all alkenes by just doing this simple little thing. I have to keep to my carbon, like that's now an alkene because it's got a double bond. I could have put that double bond anywhere, I just did it there. Boom, alkene. You no longer identify as an alkane. Represent yourself. Boom, another alkane. Another alkane turned alkene. Keeping sure that my carbons are still bonded 4 times. This carbon is bonded 1, 2, 3, 4. This carbon is bonded 1, 2, 3. All good right here. Now, ooh, I can't do that, can I? That's too many bonds. Can't do that. Okay. So remember, carbon bonds 4 times. If you're going to make carbon bond 3 or 5, better have a good reason. Right here, I can make that. Boom, alkene. Boom, alkene. Done it right here. All right, now, here's going to blow your mind. Alkynes. Alkenes have a double bond. Alkynes have triple bonds. Okay. Now, if you're going to have triple bonds, now you really got to count your carbons, where you're putting that triple bond and things like that. Okay. So, for example, let's look up here at this top right here. If I want to make this an alkyne, I have to put the triple bond like all between the carbons. Okay. Like this carbon is bonded 1, 2, 3, 4. This carbon is bonded 1, 2, 3, 4. Yes. All right. This one down here, if I want to make it an alkyne, I can put my alkyne, my triple bonds out here, and that's fine. That makes it an alkyne. But I want to do some counting in the middle to kind of show you. Don't get clumsy. Don't make this mistake. I'm going to make this carbon my triple bond here. Okay. Now I want to count everybody. Okay. So this carbon here is good. He is bonded 1, 2, 3, 4. This carbon here is bonded 1 too many. This is not going to do an alkyne type of bonding because it's already got too many bonds here. So we can draw triple bonds anywhere we want, but we also want to keep it realistic. I hope this helps. Thank you.